Hello everyone, welcome back to our YouTube channel Gurmantra Shiksha Ka Granth. I am your educator Nidhi Dua and I teach you chemistry at this platform for GATE exam. This is our chemistry syllabus for GATE exam and the topics that we have covered till now are these topics which you can see on the screen. So without any further delay, let's begin our number one topic, that is hydrogen bonding. So basically a hydrogen bond is a primarily electrostatic force of attraction between a hydrogen atom which is covalently bound to more electronegative atom or group. For example, nitrogen, oxygen and fluorine. As you can see the definition, hydrogen bonding is an electrostatic attractive force between covalently bonded hydrogen atom of one molecule and an electronegative atom, that is Phone. F stands for fluorine, O stands for oxygen and N stands for nitrogen. Nitrogen, oxygen, fluorine, the hydrogen bond donor and another electronegative atom bearing a lone pair of electron, the hydrogen bond acceptor. Such an interaction between hydrogen and electronegative atom is generally denoted by a dotted line. That dotted or dashed line indicates the hydrogen bond. This hydrogen bond is not formed in between the ionic compounds. As you know, in between ionic compounds, ionic bond is formed. And this hydrogen bond forms a polar covalent compounds. This hydrogen bond is a type of weak bond. As you know, in previous lecture, we have covered that there are two types of bond present in nature, strong bond and weak bond. Strong bond are further of many types. Number one that we have studied is ionic bond, number two covalent bond. And the weakest bond in nature is your van der Waals force and hydrogen bond. But as if we compare hydrogen bond or van der Waals force or van der Waals bond, the strongest bond is your hydrogen bond. And this hydrogen bond is also known as dipole-dipole type of attraction. The main conditions for hydrogen bonding are these. Number one is hydrogen should be covalently bonded with high electronegative element like Phone. Hydrogen atom should be bonded with high electronegative element, for example fluorine, oxygen or nitrogen. And the atomic size of the electronegative atom or element should be very small if we are talking about hydrogen bonding. The decreasing order of atomic size is nitrogen, oxygen and fluorine. In particular, this series, nitrogen has the maximum size while fluorine has the minimum size. And the order of electronegativity is fluorine has the highest electronegativity while nitrogen has the least electronegativity. As you can see and you have studied in the previous lectures that electronegativity is inversely proportional to the size of an atom. Next, this point is very important. This point tells you about the strength of hydrogen bond. As the electronegativity of element increases, the strength of hydrogen bond between atoms increases or the molecule increases. That's why it is written here, strength of hydrogen bond is directly proportional to the electronegativity of element or is inversely proportional to the atomic size. Hydrogen bond can be shown by this method. Next, the types of hydrogen bonding. Basically, there are two types of hydrogen bonding. One is your intermolecular and second is intramolecular. Intermolecular is further classified into two types of bonding, Number 1 is homo-intermolecular and number 2 is hetero-intermolecular. Let's study about number 1 type of hydrogen bonding, that is intermolecular hydrogen bonding. Hydrogen bond formed between two or more molecules of either the same or different compounds, that is known as intermolecular H bond or intermolecular hydrogen bonding. There are two types of intermolecular hydrogen bonding. Number 1 is homo-intermolecular. Hydrogen bond between molecules of same compound. As you can see from name, homo-intermolecular. Homo means same. So homo-intermolecular kind of hydrogen bond is formed between the molecules of same compound. For example, in case of H2O and HF. Hetero-intermolecular compounds are those compounds in which hydrogen bond is formed between different molecules or different compounds. For example, in case of alcohol and water. In this case, as you can see, this R group represents the alcoholic group, while this HOH is your H2O, that is water. As you can see here, the hydrogen bonding is formed in between two kinds of molecule. One is alcohol and another one is water. So this kind of bonding between two different kinds of compounds or two different kinds of molecule is known as hetero-intermolecular kind of hydrogen bonding. Next, second type of bonding is intramolecular hydrogen bonding. This intramolecular hydrogen bonding takes place within the molecule. Hydrogen bonded with electronegative element of a functional group forms hydrogen bond with another electronegative element present on the nearest position on the same molecule. This intramolecular hydrogen bond is most likely to be occurred in the organic compounds, and these organic compounds results in the formation of ring. And as you know, when the formation of ring take place, the most kind of bond found is intramolecular hydrogen bonding. Next, these are some important points which you need to remember, and these points are being explained in the few next slides. Number 1 is H2O is liquid while H2S is gas. Second point is HF is liquid while HCl is gas. And third point is viscosity and surface tension, which is explained in the next few slides. So, and the next important point is strength of hydrogen bond. In case of intermolecular hydrogen bonding and intramolecular hydrogen bonding, which are the kinds of hydrogen bonding, intermolecular hydrogen bond has the maximum strength as compared to intramolecular hydrogen bond. Now, solubility in H2O. Any organic compound which get dissolved in H2O or any polar compound that dissolves in the polar solvent, that is your H2O, it is due to the presence of hydrogen bonding. And next point is the association of molecules. Now, the application of hydrogen bonding. These are the 7 major applications of hydrogen bonding, which we are going to discuss one by one in the next slide. So, as you can see, from physical state, melting point, boiling point, viscosity and surface tension all are directly proportional to the hydrogen bond, while volatility and vapor pressure are inversely proportional to the hydrogen bonding. Number 1 is the physical state. Compounds having intermolecular hydrogen bonding generally exist in solid or liquid state. So, as you can see, the compounds which have intermolecular hydrogen bonding are in solid or liquid states. That's why HF, H2O, NH3 and HCN are present in solid or liquid state, because they have intermolecular hydrogen bonding, while these kinds of compounds have gaseous type of physical state. Next is the solubility. As solubility is directly proportional to the hydrogen bond, that's why as the hydrogen bonding increases in a particular compound, the solubility also increases. For example, in case of these series or in case of these examples, CH3CH2OH has the least hydrogen bonding as compared to CH2OH and CH2OH. This particular example has one OH, so it has the least hydrogen bonding, while this compound has 2 hydrogen. This compound will show more hydrogen bonding. And as you move from ethanol to sugar, the hydrogen bonded molecules, hydrogen bonded atoms increases. That's why the solubility also increases. As the number of OH group increases, hydrogen bonded with H2O increases and the solubility increases. Third point is melting point and boiling point. Melting point and boiling point is directly proportional to the extent of intermolecular hydrogen bonding. As the hydrogen bonding increases, as the intermolecular hydrogen bond increases, the melting and boiling point also increases. But the most famous example for this melting and boiling point is NH3, PH3, ASH3 and SPH3. You have to learn this example. This is really very important. You have to learn the order of this example. Fourth point is your density. Density increases due to the intermolecular hydrogen bonding. As the compound's intermolecular hydrogen bonding increases, the density also increases. Now, in case of density, there are three most important points which have been asked in various exams, and for GATE exam, these are the most important points. You have to learn these points, you have to write these points in your notebook. Number 1 point is density of ice is more than liquid water due to the open cage-like structure. In this particular point number 1, you have two things to learn. Number 1, the density of ice is always greater than the density of water. Why? Because of the open cage-like structure of ice. And second point is what is the structure of ice? So the answer is open cage-like structure. This question has been asked previously. What is the structure of ice? So the structure of ice is open cage-like structure. Second point is volume of water is minimum at 4 degrees Celsius. And the density of water is 1 gram per ml. Hence, density is maximum at 4 degrees C. As you know, density has the formula, density is equals to mass upon volume. As the volume decreases, the density should increases. And the volume of water is minimum at 4 degrees C. That's why density is maximum at 4 degrees C. And this point is also very important, that is below 4 degree temperature, hydrogen bond increases. As you decreases temperature, hydrogen bond increases. Fifth point is about acidic strength. As the hydrogen bond increases, hydrogen bonding increases, acidic strength decreases. As you can see here, in case of HF and HI, HF has the highest electronegativity. Fluorine has the highest electronegativity. That's why its hydrogen bonding should be high. But if its hydrogen bonding is high, then its acidic strength should be low. That's why in case of HF and HI, hydrogen fluoride has the least acidic strength as compared to hydrogen iodide. Sixth point is viscosity. Hydrogen bond is directly proportional to the viscosity and surface tension. As the hydrogen bond increases, viscosity increases and the surface tension increases. As you can see in this example, as the number of OH Ions increases as the OH group increases, hydrogen bond increases and viscosity also increases. Now I hope you all are cleared about the hydrogen bonding. Till now we have covered what is hydrogen bonding, types of hydrogen bonding and the main criteria, main conditions on which the hydrogen bond depends. Now we have some practice questions. Number 1 question is, the strongest hydrogen bonding exists in? You have 30 seconds to solve this question and your time starts now. Okay guys, so let's see the answer for this question. The question is, strongest hydrogen bonding exists in hydrogen sulfide, hydrogen fluoride, ammonia and water. So the correct answer should be option number B, hydrogen fluoride. Why? Because you know fluorine has the most electronegativity. So if the element has more electronegativity, then it should form a most stable hydrogen bonding. So the correct answer should be second, hydrogen fluoride. Next question is, two ice cubes are present over each other until they unite to form one block. The force mainly responsible for holding them together is. Two ice cubes are placed on each other and the ice cubes are being holded together. So the force that is responsible to hold them together is van der Waals force, dipole-dipole interaction, hydrogen bonding or covalent bonding. The correct answer should be hydrogen bonding. So the correct answer is option number C. Next, you have true or false. You have to tell a hydrogen bond that forms a stronger chemical bond than a covalent bond. Statement says a hydrogen bond forms a stronger chemical bond than a covalent bond. This statement is true or false. So this statement should be false. Why? Because you know in nature two kinds of bonds are present, stronger bond and weaker bond. Stronger bonds are covalent bond, ionic bond, metallic bond, etc. While weakest bond is van der Waals force of attraction, van der Waals bond or hydrogen bond. Hydrogen bond is stronger than van der Waals bond, but it is weakest bond in the nature. So this statement is wrong. Covalent bonds are the most strongest bond in nature, while hydrogen bond are the weakest bond. So the answer is false. This statement was wrong. Next question number 4 is, ice has dash density as compared to water. You have learned this question in previous slide that ice has the maximum or higher density as compared to water. So the correct option should be A. Next question number 5 is, hydrogen bond is what kind of attraction? You have 30 seconds to answer this question. Okay guys, so the correct answer should be option number A, that is dipole-dipole interaction. As you know, hydrogen bond is formed between hydrogen and the most electronegative element. Hydrogen is your plus species, while any electronegative element is your negative species. And dipole-dipole forces are the attractive forces between the positive end of one polar molecule and the negative end of another polar molecule. These dipole-dipole interaction or forces are much weaker than ionic or covalent bonds and have a significant effect only when the molecules are involved are closer together. So now the correct answer should be option number A. Now I hope you all are cleared about the hydrogen bonding. Now in case if you are new here at our YouTube channel Gurmantra Shiksha Ka Granth, please do like, share and subscribe. You can also join our Telegram channel for more new updates, and for any query you can mail us on tanejanehaofficial@gmail.com, or you can also contact us on the given number. Thank you very much.